Good morning, students. Today we are going to discuss the remaining part of exercise 13.2, and we will discuss here a few parts of sum number 11 where we have to find the derivative of the first part is sin x cos x. So here we have product of two functions, one is the sine function and other is cos function. So we will take it either we will take it let y equals to the given function, or we can say let f of x equals to given function. And now we have product of two terms. Okay, so in order to find the derivative of two terms, we will just apply the product rule, that is uv whole dash, it is equals to u dash v plus v dash u. That means one by one we will find the derivative of both the terms while keeping the other term as such. So we will write down here differentiating both sides with respect to x. So y will become dy by dx, and here when we differentiate, first of all the derivative of sin x and cos x we will keep as such, then sin x function we will keep as, and the derivative of cos x. Okay, so we know the derivative of sin x is cos x into cos x function as such, plus this sin x function is coming as such, and the derivative of cos is minus sin x. So here this cos function has come as such. So here we have cos square x minus sine square x. You can end the answer here, or we also know cos square a minus sine square a is equals to cos 2a. So this can be written as cos 2x also. So any one answer we can give here, right? Similarly, let us do third part. Now in the third part, again we will take whatever function is given, we will take let y equals to that. So here we have 5 secant x plus 4 cos x. Okay, now cos function derivative we know it directly, but secant function till now we don't know what is the derivative of secant. So for that, what we will do, we can write this secant function as 1 by cos, and then we can apply our rule to find the derivative. So here we will write it as, it will become 5 upon cos x, and this plus 4 cos x we will keep as such, and now we will differentiate both sides. So differentiating both sides with respect to x we do, and it will become dy by dx equals to d by dx of 5 by cos x. Now both the terms are separate terms, so both the terms will get differentiated separately. 4 cos x. Okay, this 5 is constant, we can keep it as such, we can bring it even outside the differentiation. Similarly 4 into cos x, 4 is constant, so this constant we will bring outside the derivative. So it will become 4 into d by dx of cos x. That means 4 into derivative of cos x, and we know the derivative of cos x is minus sin x. But here we have 5 upon cos x. So here how we will differentiate? We know we will apply here quotient rule. We know the derivative of u upon v. It is u dash v minus v dash u divided by v square. Right? So in the first term we will apply this rule, and the second term direct differentiation will be done. So here we have the denominator is cos x, so cos square x it will become u dash, the derivative of 5 cos x as such, minus u as such, derivative of denominator, so 5 as such into derivative of cos, plus for this term 4 will come as such into derivative of cos x. Right? 5 is constant, so the derivative of constant is 0. 0 into something will be 0 only. So minus, we have minus 5, cos x derivative is minus sin x whole divided by cos square x, and cos x derivative is minus sin x. Right? So final answer we will have here 5 sin x upon cos square x minus 4 sin x. We can end the answer here also, or sin upon cos we know, we will write it as 5 sin x upon cos x into cos x. So sin upon cos will become tan x, and 1 upon cos is secant x. So if you want, we can give this answer like that also. I am just writing it here. So it will become 5 tan x 1 upon cos secant x minus 4 sin x will come as such. So we can give the answer like that. Why? Because sin x upon cos square x, it can be written as sin x upon cos x into 1 upon cos x. Sin upon cos is tan, 1 upon cos is secant. So this is what we have written here. So this will be our final answer for this sum, right? Similarly, second part you will do secant x. So secant x we will write down as 1 by cos x. Same way as we have differentiated 5 by cos x, instead of 5 we will have 1. So 1 upon cos x, again quotient rule you will apply, and the derivative will be secant x tan x. Okay. And now sum number 4, fourth part also, cosecant x. Cosecant x, this fourth part also you people will do. Cosecant x we will write down as 1 by sin x, and again quotient rule we will apply. Now we will do here fifth part of this sum, right? So fifth part we have the function 3 cot x plus 5 cosecant x, right? So this 3 cot x can be, now cot can be written as cos by sin, and cosecant also can be written as 1 by sin. So let us simplify it. We will have here 3 cos x upon sin x plus 5 upon sin x. Now it is our choice. If we want to differentiate separately both the terms, so in both the terms separately we will apply quotient rule, but both the terms are having the same denominator, so we can combine the terms also, and we can take the LCM here and then differentiate. Okay, so it is totally your wish. You want to apply the quotient rule separately in both the terms or collectively after taking LCM. So here I am just writing it collectively. LCM is sin x. So here we will have 3 cos x plus 5. So this is our function y, and now we will write down differentiating both sides with respect to x. So it will become dy by dx equals to. So let me write down here formula. The formula is u upon v whole dash is equals to u dash v minus v dash u upon v square. So this is our u and the denominator is v, right? So here we will have 3 cos x plus 5 whole derivative, denominator sin x will come as such, minus numerator 3 cos x plus 5 will come as such into derivative of denominator sin x whole divided by square of the denominator, that is sin square x, right? So 3 cos x plus 5 derivative. 3 as such, derivative of cos is minus sin, so it will be minus 3 sin x. Derivative of 5, it is 0. Sin x will come as such, minus the function 3 cos x plus 5 will come as such. Derivative of sin x is cos x whole divided by sin square x as such. Let us simplify. Minus 3 sin x into sin x, it will become minus 3 sin square x. 3 cos x plus 5 into cos x. So these two terms will get multiplied by cos, minus sign is there. It will become minus 3 cos square x minus 5 cos x whole divided by sin square x. Now we can separate the terms, or if you want minus 3, if I take common here, I am getting 3 sin square x plus cos square x minus 5 cos x as such whole divided by sin square x. Sin square plus cos square, it will become 1. So we have minus 3 upon sin square x minus 5 cos x upon sin square x, right? 1 upon sin is cosecant. So 1 upon sin square will become cosecant square. So it will be minus 3 cosecant square x minus 5 cos upon sin. So 1 cos upon sin will give us cot x, and 1 sin is left in the denominator, that will be written as cosecant x. So this will be our answer, minus 3 cosecant square x minus 5 cot x cosecant x. This is the answer, right? This is how we are doing the differentiation. We are applying here quotient rule, and if you notice, we are getting the formulas as well. So the derivative of cot x will be minus cosecant square x, and the derivative of cosecant x is minus cosecant x cot x. These formulas we will apply directly in class 12 sums, right? So here we are learning also, and we are solving the sums as well. Sixth part, it is directly you people can do it. Derivative of sine, derivative of cos, and 7, which is constant, that is derivative will become 0. Seventh part, 2 tan x minus 7 secant x. So tan x will be written as sine by cos, and secant will be written as 1 by cos. Once again, as we have taken here sine common, means LCM sine will be there. In seventh part, when you take the LCM, denominator will be cos x. So seventh part also I am leaving for you people. You will do that, and with this our exercise 13.2 is over, right? And now we will discuss few sums of miscellaneous exercise of this chapter, right? So in miscellaneous exercise, first sum, there are 4 parts and we have to find the derivative of these functions from the first principle. So the very first function is minus x, okay? So this minus x means we will take let f of x is minus x. This is the function, and from the first principle I will write down from the first principle how we find the derivative. If you people remember, it is f dash x will be written as limit h approaches to 0 f of x plus h minus f of x whole divided by h, right? F of x is given, we will find f of x plus h. F of x is there, divided by h, and limit h approaches to 0. So this is limit h approaches to 0. If f of x is minus x, so f of x plus 1 will be minus of x plus h. In place of x, x plus h will come, minus sign. F of x is already minus x, so that I will write down in bracket whole divided by h. So what is coming? Limit h approaches to 0. Let us open the bracket, minus x minus h plus x divided by h, right? So this is further equals to limit h approaches to 0. Minus x plus x cancel. It is minus h upon h, that is limit h approaches to 0 minus 1. So this is constant. There is no effect of this limit over here. So the answer is minus 1. Even now, we know our formulas directly, and we know the derivative of minus x will be minus 1. But here we have done the same thing from the first principle. So if it is mentioned that we have to find the derivative from first principle, we are supposed to follow that only. If I give this answer straightforward without application of first principle, the marks won't be given, okay? Similarly, second part you people will do. It is minus x raised to power minus 1. So when I do this thing, I'm just writing it, f of x is minus x raised to power minus 1. That means it is minus 1 upon x, okay? So f of x, if this f of x plus h will become minus of, means minus 1 upon x plus h it will become. Same way you will apply first principle, substitute the values, simplify it, apply the limit, you are getting the answer, right? Now we will discuss here third part. And third part, the function is sine of x plus 1, right? So our function is given, you people have to complete it. The third one, the second one, it is sine of x plus 1. So we will write down from the first principle. From the first principle, f dash x is equals to limit h approaches to 0 f of x plus h minus f of x whole divided by h. So this will become limit h approaches to 0. If f of x is sine of x plus 1, f of x plus h will become sine of x plus h plus 1. In place of x, x plus h will come, minus f of x as such, that is sine of x plus 1 whole divided by h. Right? Now if you want, you can do it by the method, you can apply the formula sin a plus b, and subtract, cancel the common terms, or the easy way, this is one angle sine of x plus h plus 1. So if I keep this as c and x plus 1 as d, so I can apply here sin c minus sin d formula also, right? And we know what is sin c minus sin d formula. Sin c minus sin d formula is 2 cos c plus d by 2 sin c minus d by 2. So we will apply that formula, 2 cos c plus d by 2 and sin c minus d by 2, and we are getting our answer. Okay, so I'm just shifting this term on to the next page, and then we will continue with the formula. So here we have sin c minus sin d. I have just written the formula over here. We will apply this rule, okay, and after that only we will apply the limit. So limit h approaches to 0, we will write down as such. In the numerator we are going to apply this formula, so it will become 2 cos, this is c and d, so c plus d is x plus h plus 1 plus x plus 1 whole divided by 2. So c plus d by 2 sin c minus d by 2, that is x plus h plus 1 minus x minus 1 whole divided by 2, and this part is whole divided by h. So it is becoming limit h approaches to 0. Here plus x plus 1 minus 1 get cancelled. X plus x, 1 plus 1. So 2x plus 2. We have 2 cos 2x plus 2 plus whole h divided by 2. And here we are left with sin h by 2 divided by h. Right? Now here we will apply our rule in that we have learnt in the exercise limits. If you people remember, we have done limit x approaches to 0, sin x by x, it is equal to 1. So that formula we will be applying here. So here 2x plus 2 plus h plus 2, and this 2 is extra in the beginning, and we have sin h by 2. The angle of sin is h by 2. According to this formula, I am just writing the formula here. We have limit x approaches to 0, sin x upon x is 1. So the angle of sin and this, if both are same and the same is approaching to 0, it will be 1. Angle of sin is h by 2, denominator we have h. So this 2 I can bring to the denominator and it can be written as h by 2. So if h approaches to 0, h by 2 will also approach to 0. So that formula we are going to apply here. So here we have this thing into sin h by 2 divided by h by 2. So this step is important. You know, both the terms are in product. So either I write down h whole or with one term in the denominator, it is absolutely correct. I hope you people understand this thing. So when I am writing whole divided by h, or only if I write this h in the denominator of sin, at the end, you know, both the terms are in product. So it is one and the same thing. Either I write down this way or here. And this 2 which is written in the numerator, I have brought to the denominator of h. So it will be written as sin h by 2 upon h by 2. So now let us separate the limit and apply the limit. So here we have limit h approaches to 0, cos of 2x plus 2 plus h divided by 2 into limit h approaches to 0, sin h by 2 upon h by 2. So this will give you 1 as per this result, and here when we apply the limit, this h only will become 0. So we are left with cos 2x plus 2 plus 0 divided by 2 into 1, right? So 2 throughout get cancelled, it will be cos of x plus 1 answer. Also we know the derivative of sin is cos only, and the derivative of sin x plus 1, it will be cos of x plus 1 only. So same answer we are getting, but how we got it? By the application of first principle, right? So this is the third part of the sum. In the fourth part, you have cos of x minus pi by 8. I will just give you the hint here. So the function is cos of x minus pi by 8. X is a variable but pi by 8 is constant. So it is same, as in the previous sum, we were given sign of x plus 1. 1 is also constant, pi by 8 is also constant, okay? So as we treated 1 in the third part, same way we will treat pi by 8 here. So when you find f of x plus h, it will become cos of x minus, x plus h, right? X plus h in place of x plus h, and this minus pi by 8 will remain as such. Okay, so this formula means this f of x plus h value we will use in our first principle. F of x we will use, apply the formula. So there you will get cos c minus cos d. As we have in the third part we applied sin c minus sin d. So here this function minus this. So this angle you will take as c. This angle if you take as d, cos c minus cos d formula we will apply, and then simplify and apply the limits. You will get your answer. So this part also you people will complete. Okay, and I want, we have discussed the product rule, quotient rule, and the general differentiation formulas in previous exercise. So you people can complete this miscellaneous exercise till sum number 8. So your homework is till sum number 8 miscellaneous exercise, and the previous 13.2 sum number 11 that we have done. So that much you people can complete today, and the remaining part of the exercise we will discuss in the next class. Thank you, students.